Okay, so these notes are over addition and subtraction of rational numbers. We treat rational numbers just like we do normal fractions. So when we multiplied, we were able to multiply straight across. When we divided, we multiplied by the second rational's reciprocal, copy dot flip, and then we multiplied straight across and simplified. For addition and subtraction, we are going to treat them just like normal fractions, so we have to have a common denominator. So just to brush up on getting common denominators, we're going to do a couple of basic fractions. So 6 over 5 plus 2 over 8. What we can do here to start off is we can simplify 2 over 8 to 1 over 4. So really we're dealing with 6 over 5 plus 1/4. We still don't have a common denominator though, so what we can do here is to get a common denominator, we've got one denominator that's 5 and the other that's 4. So a good common denominator is 20. So to get 20, I'm going to multiply 6 over 5 top and bottom by 4. And then 1 over 4 top and bottom by 5. So this becomes 24 over 20 plus 5 over 20, which when we add, we're going to add the numerators. So 24 plus 5 is 29. Ooh. Over when we add and subtract fractions, the denominator stays the same. So it's going to be 29 over 20. And then you check and see, can you simplify? Are there any numbers that go into 29 and 20? Which there isn't, so we end up with 29/20. All right, for 3 over 4 minus 2 over 3, we don't have a common denominator, and we can't simplify either. So looking at our denominators of 4 and 3, a good common denominator is 12, so I can multiply 3 over 4 top and bottom by 3. And 2 over 3 top and bottom by 4. And I get 9/12 minus 8/12, which when we subtract 9 minus 8 is 1 over 12. All right, so when we add or subtract rational expressions with like denominators, we just add or subtract the numerators and then put the result over the common denominator. So here we're already given 4 over 3x plus 5 over 3x. Both of our denominators are already 3x. So since I already have a common denominator, I can go ahead and add together the 4 plus 5, giving us 9 over 3x. And the 9 and the 3 both will simplify by 3, resulting in 3 over x as our final answer. And if we also wanted to state our excluded values, we can say that x cannot equal 0. Because if we plug in 0 right there, then we'll divide by 0, and that's not allowed. That is undefined. So here I have 6x plus 5 over x squared minus 3 plus 3x minus 1 over x squared minus 3. Both of my denominators are x squared minus 3, which is good. So I can go ahead and write this as one big fraction. So I can say that this is 6x plus 5 plus 3x minus 1 over x squared minus 3. And now I can combine like terms. So 6x and 3x make a 9x. And 5 and negative 1 make plus 4 over x squared minus 3. This next one is a little trickier. So 3x squared minus 5 over 3x minus 1 minus 2x squared minus 3x minus 2 over 3x minus 1. This one's a little trickier because you have to distribute your negative. So first we can write it as one fraction since we already have a common denominator. So we can say that it's 3x squared minus 5 minus 2x squared minus 3x minus 2 over 3x minus 1. So now I'm going to make sure to distribute out my negative. So it's going to go to all three of these terms. So I have 3x squared minus 5 minus 2x squared plus 3x plus 2 over 3x minus 1. And then combine like terms. So 3x squared and negative 2x squared make 1x squared plus 3x. And then negative 5 plus 2 is negative 3 over 3x minus 1. So please, please, please do not forget to distribute out that negative. Next up, I have x over x plus 3 plus 2x plus 6 over x squared plus 6x plus 9. So I do not have a common denominator. And when I do not have a common denominator, your first step needs to be to factor everything. So I cannot factor x any further, so it's just going to stay x. Over x plus 3, I can't factor any further. Plus 2x plus 6, that actually factors, so I can factor out a 2. And I've got x plus 3. Over x squared plus 6x plus 9 factors to be x plus 3, x plus 3. And looking at our rationals, your first step was to factor. Your second step needs to be, can you simplify any of your rationals, either one of your rationals? So x over x plus 3, I can't do anything else to. But 2 times x plus 3 over x plus 3 times x plus 3, I can get rid of an x plus 3 in the top and the bottom. So I'm left with x over x plus 3 plus 2 over x plus 3. And now I have a common denominator. So I can add going straight across. So I get x plus 2 over x plus 3. And then if I'm stating my excluded values, x cannot equal negative 3. I've got 2 times x minus 3 minus 5x plus 7 over 3x minus 9. I don't think it's, I have 2 over x minus 3 minus 5x plus 7 over 3x minus 9. I don't know what I just said a second ago. Ignore that. Okay, so I do not have a common denominator right off the bat. I've got a denominator of x minus 3 and another one of 3x minus 9. So my first step needs to be to factor everything. So I can't factor 2 any further. Over I can't factor x minus 3 any further. Minus, I can't factor 5x plus 7 any further. Over 3x minus 9, that'll actually factor, so it's 3 times x minus 3. So looking at our denominators, I can't simplify either of my rationals. 2 over x minus 3, nothing happens, and 5x plus 7 over 3 times x minus 3, nothing happens. So now I need to look at my denominator. They both have an x minus 3 in common. However, I have one denominator that has an extra 3 being multiplied, and the other one doesn't have that. So what I can do to get the other one to have it is I can multiply top and bottom by 3. So now I have 6 over 3 times x minus 3 minus 5x plus 7 over 3 times x minus 3. And now I have a common denominator. So now I need to put it together. So I have 6. I'm going to distribute my negative to both. So minus 5x minus 7 over 3 times x minus 3. And then I can combine like terms. So I get negative 5x minus 1 over 3 times x minus 3. So I used multiplication to get me that common denominator that I needed. Okay, I've got 2 over x squared plus 9x minus 10. Plus 3 over x squared plus 4x minus 5. So I don't have a common denominator, which means I need to factor everything. So I can't do anything else to 2 over x squared plus 9x minus 10 factors to be x plus 10, x minus 1, plus 3, I can't do anything else to, over x squared plus 4x minus 5. Oh, I'm sorry, I didn't factor that. That was kind of silly. I need to factor that. So that factors to be x plus 5, x minus 1. Now, looking at our rationals, I can't simplify either. So I'm looking at my denominators. They both have an x minus 1, which is good. They share that x minus 1. However, my first rational has an x plus 10 that the second one doesn't have. So that second rational needs an x plus 10. So I'm going to multiply top and bottom by an x plus 10. Well, now looking at them, my second rational has an x plus 5 that the first rational doesn't have. So I'm going to multiply top and bottom by an x plus 5. So now both of my rationals have an x plus 10, an x minus 1, and an x plus 5 in the denominator. So when I go to multiply this out, I need to distribute my 2, and I'll distribute my 3. So this is 2x plus 10 over x plus 10, x minus 1, x plus 5, plus 3x plus 30 over x plus 5, x minus 1, x plus 10. And it doesn't matter what order your denominator is written in as long as all 3 factors are included. And now we can go ahead and combine our like terms. So 2x and 3x make 5x. 10 and 30 make plus 40 over x. Oh, God. Oops. Give me a second. Sorry. Over x, oh my gosh, x plus 10, x minus 1, x plus 5. And our excluded values are that x cannot equal negative 10, positive 1, and negative 5. So there's my final answer. So you're using a lot of multiplication to get common denominators. And then once you get a common denominator, you'll multiply out whatever the numerators need you to multiply. And then combine your like terms. And that is it for adding and subtracting rationals.